एक ही स्टूडेंट है लाला जी,
एक नहीं है,
देखो एक ही दिख रहा है।
यहाँ से रिफ्रेश करना। ओके,
इज इट, क्या पूछो है, दिमाग की दही हो रखी है। Yes, I am receiving your messages and I am also audible. Thank you guys for your response. I hope we will not face the same issue once again. So guys, where were we? We were talking about the kinetics. So how fast the process is. So tell me, which parameter help us to identify whether the given process is fast or slow? Time, rate, means time of the process, rate of the process, both or none of these. We need some other parameter. Tell me. हेलो गाइस, अब तो आंसर कर दो यार, प्लीज आंसर, टेल मी. सी, बोथ, रेट, रेट, both, both. Okay, you are saying both, one is saying time. तुम्हारा क्या कहना है? Both. So let's see. Suppose there are two people. Suppose there are two people, Mr. A and Mr. B. Okay. They have to cover a distance from point P to Q. A moves at a rate of 40 km per hour. B moves at a rate of 60 km per hour. A covers this, A reaches to Q in 1 day and B reaches to Q in 2 days. This is city P and this is some city Q. The average speed of the journey for A, it was 40 km per hour, for B it was 60 km per hour. A reaches in 1 day, B reaches in 2 days. So if you are talking about rate, then the rate of B is high, obviously, as we can see 60 km per hour is greater than the 40. And if you talk about the time, then A reaches in 1 day, B reaches in 2 days. So tell me, who is fast? Tell me, who is fast? A or B? But most of you are saying that rate is used to identify whether the given process is fast or slow. Let me take one more example. I hope all of you are aware with the Olympic Games. In Olympics, there are so many games are there. Athletics is also there. In athletics, we talk about the 100-meter race, 110-meter hurdle race, 400-meter relay race. So many races are there. So in any race, when we have to identify who is the winner, what we use? We use to calculate the time of the person or the speed of the person. Which parameter do we use? Time or speed to identify who is the winner in this 100-meter race and 400-meter race? Tell me. Information is contradicting. How B can take more time if its speed is more? Because B is moving from some another route and A is moving from some another route. Time. Okay. And let me take one more example. Okay. Now I hope you will relate. Let me talk about some radioactive decay. That is one reaction. All of us know that. And we also know that in radioactive decay, normally the half-life of the component is in thousands years or hundred of years. Okay. So if half-life of any component is in hundred of years or maybe in days, then that component, that radioactive reaction will complete in n days, in infinite days we can say. Infinite means very long time span. And if I talk about combustion reaction will get complete within fraction of seconds. Okay. So tell me, out of these two, which is the fast reaction, combustion or radioactive decay? Let me tell you, radioactive decay, the rate of disappearance of radioactive decay is 10 to the power 6 mole per second, suppose. And for combustion it is 100 mole per second only. Okay. Whatever the rate is, doesn't matter. When we talk about the process, when we talk about anything in life, we always use time to determine, to identify whether the process is fast or slow. Okay. We don't talk about the rate. For example, if any person dies in very young age, then the people say he is gone so soon. And if a person dies at an age of 65, 70, 80, 90, 100 years, then no one says that he dies so soon. So it's all about the time of the process, time of the thing, not the rate. Remember this. So kinetics means how fast the process is. And how can we identify that whether the given process is fast or slow? With the help of time. Okay. That's it. Now the question is, if time is helping us to identify that the given process is fast or slow, then what is the role of the rate? Why we are using rate of the process? Then the answer is simple. Rate help us to calculate the time. That's it. Rate help us to calculate the time. And with the help of time, we define the process. It is fast or slow. So I hope it is clear to all of you. Now, contacting pattern. Is it clear, guys? At least say yes, no. Respond, please. Okay. Next is contacting pattern. So what is the meaning of contacting pattern? So contacting pattern means the flow pattern and interaction of molecules in reaction mixture. Contacting pattern means flow behavior, flow pattern of the reaction mixture, the interaction between the molecules in the reaction mixture which is present in the reactor. Okay. Now the question is, what is reaction mixture? Because this term, entire CRE is depends on this term, you can say reaction mixture. So for reaction, in short, I am writing RXN. It means reaction. Okay. So what is reaction mixture? Before we talk about the reaction mixture, let's talk about another term which is very basic, and I hope all of you using this term from your class 9th or 10th maybe. Mixture. So tell me guys, what do you understand by this term mixture? What is mixture? Bolo.
It is a homogeneous combination of two components.
Okay. Homogeneous combination of two components. Okay guys, and anyone else? See, our first two lectures will be very basic and introductory, where you will get to know the so many terms and their meaning. Tell me, what is mixture? How will you define this term mixture? Okay, leave it. Mixture we can define in simple words. We can say mixture is the combination of two or more components. Okay, two or more components can be of different types, or mixture we can also have a same component of at different temperatures. Like if you mix hot water and cold water, that is also a mixture. So two or more components, and simple. Yes, wonderful. And based on the phase, we can classify the mixture into two categories. That is homogeneous mixture and heterogeneous mixture. So, what is homogeneous mixture, guys? In one line. Okay, I don't want to write the essay. Just answer this in one line. How will you define this term, homogeneous mixture? I know most of you are comfortable in over WhatsApp, Facebook, Instagram, Twitter, on so many other things. But use this chat box as well. Be comfortable with this as well. Tell me. Same phase. Homogeneous mixture, same phase. Okay. Mixture which exists in same phase, I guess. Reactant, product and catalyst in same phase. Where is the reactor? I am talking about the mixture. Reactant kahan se aa gaya isme, Tisha? One phase. Okay. Same phase. Now there is a point. Two of you are saying homogeneous mixture exists in same phase. One of you is saying it exists in one phase. Same phase, one phase. Same phase, one phase. Is it different? Ketan, Homogeneous mixtures have the same composition throughout. See guys, homogeneous mixtures are those which exist in single phase, one phase only. We can't use the term same phase. For example, if I add water and oil, both are liquids, liquid, but all of us know that, and that the mixture of water and oil will not be homogeneous. That will be a heterogeneous mixture. Okay, so remember this, never use this term. Homogeneous mixture means same phase. No. Homogeneous mixture which exists in one phase. That's it. Irrespective of the phases of the components. The phase of the components does not matter. Like if you add salt in water, salt is solid, water is liquid, but the combination of salt and water will be a one phase mixture. That is homogeneous mixture. So remember this, the phase of the components does not matter in this case. Homogeneous mixture exists in same phase. No same phase. Don't use this word same. Use the word single or one phase. Okay, that's what I am telling you. Like if we take the example of water and oil, both are in liquid phase, means same phase, but it is not a homogeneous mixture. Okay, so be careful with this. Heterogeneous mixture which exists in more than one phase. And I hope it is clear to all of you what is phase. If it is not clear, then I am giving you one day time, search what is phase, and we will discuss this thing in next class. What is phase? What is the meaning of this term, phase? Okay. So what is reaction mixture? Reaction mixture means combination of more than one components. Reaction mixture means which formed due to chemical reaction. Okay, for example, in a feed I have only one component, that is A. When this A enters into a reactor, reaction will start, A will convert into B. So during the reaction, remember this, during the reaction I have two components, at least I have two components, reactant and product, and we know that combination of two or more products is called a mixture, and this mixture is formed due to reaction. So this is a reaction mixture. And remember guys, reaction mixture may consist of only four components. In reaction mixture we will have only four components. One, reactants. Second, products. Third, catalyst. And fourth, inerts. So reaction mixture may comprise of reactants, products, catalyst and inerts only. Other than these four, if we have any fifth component present in the mixture, then that will not be a part of reaction, and that will be called as impurity. Other than these four, if we have any fifth component in the reaction mixture, that will be an impurity. So I hope it is clear to all of you. And as mixture can be classified into two categories, homogeneous and heterogeneous mixture. If mixture exists in one phase, that is homogeneous mixture. If mixture exists in more than one phase, that is heterogeneous mixture. Similarly, reaction mixture can be classified into two categories. One is homogeneous reaction system. Based on the phase, reaction system can be classified into two categories: homogeneous reaction system and heterogeneous reaction system. As the name suggests, homogeneous reaction system means when reaction mixture exists in one phase, and heterogeneous reaction system where reaction mixture exists in more than one phase. So, let me take one example. When we talk about the ammonia synthesis, see, nitrogen gas phase, hydrogen gas phase, ammonia gas phase, and we know that all gases are completely miscible, all solids are completely immiscible. So, since all these three components are in gas phase, so it will form a single phase mixture. So this is the example of homogeneous reaction system, because this entire reaction mixture exists in one phase, that is gas. Okay, and if we use a catalyst, and in ammonia synthesis we know that normally we use iron as a catalyst. So if we use iron as a catalyst which is in solid phase, now we know that gases and solids are non-miscible, okay, immiscible. So you can see reaction mixture exists in more than one phase, solid and gas. This reaction mixture exists in two phases. So this will be the example of heterogeneous reaction system. I hope it is clear to all of you. And next is performance equation. And what is performance equation? As the name suggests, any equation which relates the variables which will help us to find out the performance of the system, performance of the reactor. Okay, so performance equation will be the mathematical equation where we can relate the input variables with output variables, with kinetics variables, and some contacting pattern, variables of the contacting pattern, etc. So any mathematical equation which relate input variables with output variables, kinetics and contacting pattern variable, that will be the performance equation. So now let's start. So first we will talk about the chemical kinetics. Okay. Second, contacting pattern. So contacting pattern is not in our syllabus, so we will not talk about that. We will talk about the kinetics and then performance equation. So first, chemical kinetics. So in kinetics, first term is reaction time, which is denoted by small t. We will use the standard notations. So what is reaction time? As the name suggests, reaction time will be the time required to complete the reaction up to the desired extent. Time required to complete the reaction up to the desired extent. Next point will be the rate of reaction. Which is denoted by small r. And rate of reaction we can define in n number of ways. We can define the rate of reaction, rate of the entire reaction with the notation small r. And we can also define the rate of the reaction with respect to components participating in that. Okay, means rate of reaction with respect to reactant, rate of reaction with respect to product. So for any component I, if I want to define, I know that rate of reaction with respect to component I will be directly proportional to the dNi over dt. dNi over dt means rate of change of moles of component I, where capital N is used to represent the number of moles. So Ni means number of moles of component I. So dNi over dt means rate of change of moles of component I. So when we talk about the rate of reaction, we can classify the rate of reaction into, we can define the rate of reaction into three ways mainly. Okay, if you see the books, you may find n number of bases, but we will talk about only three of them. First, based on the unit volume of reaction mixture, that is Ri is equal to 1 over V dNi over dt, where V represents the volume of reaction mixture. Okay, so guys, in SI system, what will be the units of this? In a SI system, what will be the units of Ri? Tell me. तुम बताओ. कैसे? कुछ तो कैलकुलेट किया होगा ना. तो सेकेंड इनवर्स कैसे आ रही है? Hello guys, if you will not respond here, then I will assume you guys are sleeping, and if I assume you guys are sleeping, then what will I do? I will also sleep. साथ में सोएंगे सब. सेकेंड इनवर्स कैसे हुआ बोलो ना. सॉल्व किया कुछ कैलकुलेशन या ऐसे ही हवा में? कहाँ पढ़ा? कौन सी बुक? थैंक यू ये बताने के लिए. बुक में ऑब्वियसली, अखबार में तो आएगा नहीं. कौन सी बुक में पढ़ा था? जिस बुक में भी पढ़ा था कि रेट ऑफ रिएक्शन की यूनिट बेस्ड ऑन यूनिट वॉल्यूम ऑफ रिएक्शन मिक्सचर सेकेंड इनवर्स होती है, उस बुक को फेंक देना कचरे के डिब्बे में, या फिर किसी को भी मत देना, किसी गरीब को भी देके फायदा नहीं है, उसका करियर बर्बाद हो जाएगा होने से पहले। तुम्हारे जीवन में अगर कोई तुम्हारा शत्रु हो, दुश्मन, जिससे तुम बहुत नफरत करते हो, जिससे तुम चाहते ही नहीं जीवन में कि ये सक्सेसफुल हो, उसे वो बुक दे देना और उस बुक को अपने से दूर कर देना, ठीक है। बिकॉज इन एसआई सिस्टम द यूनिट्स फॉर मोल्स आर ग्राम मोल और यू कैन से मोल. For volume it will be meter cube and time it is second. So this is the unit of rate of reaction. Rate of reaction के किसी भी फॉर्म की यूनिट सेकंड इनवर्स कभी नहीं होती है. Next is based on unit interfacial area of fluid system, two fluid system, two phase system, or in simple words you can say multi-phase reaction system. Obviously we cannot use the same notation. These are two different bases to define the rate, so we have to use some different notations. So let's say Ri double dash, that is 1 over S dNi over dt. And what will be the units? As you can see, moles per meter square per second. Mole per meter square per second. And last is based on unit mass of catalyst in solid fluid catalytic reaction system, that is Ri dash is equal to 1 over W dNi over dt. Units will be mole per kg per second. क्लास में बैठा हुआ रेट कांस्टेंट की बात कर रहा, रेट नहीं. तुम ऑनलाइन होते हुए रेट क्लास वाले बंदे की बात कर रहे हो. केतन गांधी, यू आर प्रिपेयरिंग फॉर गेट एग्जाम और यू आर प्रिपेयरिंग टू बी द पॉलिटिशियन. फोकस ऑन योर सेल्फ, नॉट एनीवन एल्स. एंड सेकंड थिंग, इफ यू वांट टू criticize someone, first check yourself as well, because even for the rate constants, units are not second inverse. And if you want to say for rate constant unit is second inverse, then mention that rate constant is of first order. Anyways, leave it. So guys, this first method we use for homogeneous reaction system. And these two methods are used for heterogeneous reaction system. And why? That we will discuss when we talk about the heterogeneous reaction system only. So from now onwards we will talk about the homogeneous reaction system. Okay. From now onwards, whatever we will discuss, that will be all about the homogeneous reaction system. And why we use this method for homogeneous and these two methods for heterogeneous only, that we will discuss at the time of heterogeneous reaction system. So, rate of reaction for homogeneous reaction system, we know that Ri is equal to 1 over V dNi over dt. This is the rate of reaction. So, for example, suppose we have some chemical reaction, A gives B. Then how can we write the rate of reaction for these two components? For reactant A, I hope it is clear, that is a very basic thing. I didn't discuss what is reactant and what is product. During the reaction, the component which is disappearing, for which the amount is decreasing, that is known as reactant, and the component for which amount is increasing, which is appearing, forming during the reaction, that is called product. Okay, so for reactant A and for product B. So, as per the definition of rate of reaction, Ra can be written as 1 over V dNa over dt. Similarly, for product B, Rb will be equal to 1 over V dNb over dt. Now, just try to understand, guys. In our life, we also want to go in some forward direction, and every process is also tries to move in forward direction. Okay, that's why you are coming in this coaching and preparing for GATE exam, because you think after preparing for GATE exam and getting good rank in GATE 2021 exam, you will move forward in your life. So just try to understand, we are moving in forward direction. Okay. So the value, if this is some value, let's say x, this is some variable x. So you can see the value of this variable x is continuously increasing. As we are moving ahead, the value of this parameter is increasing. So it means the final value will always be greater than the initial value. Okay. So this change, when we are moving in forward direction, then always this change will be, we know that change of any scalar quantity defined as the final value minus the initial value. So this change will be positive always. So similarly, if I talk about the rate of any process, either it is rate of distillation, rate of sedimentation, rate of heat transfer, or rate of reaction, we are moving in forward direction. So this rate will also should be a positive quantity as well. Okay. So now here, if I talk about the product, so DNB means change in moles of component B, that is product B. Change means final moles of B minus initial moles of B. And as B is the product, so we know that the amount of product will increase continuously. So the value of this difference will be positive. And since this is positive, so Rb will be equal to dNb over dt. We can write, it will be like this only. But when we talk about the A, DNA means final moles of A minus initial moles of A. And A is the reactant. We know that as we move, as the process moves ahead, as the reaction proceeds, the amount of A will decrease. And as the amount of A is decreasing, So final moles of A will be less than the initial moles of A, and this value will be negative. And as DNA is negative, so rate will become negative as well. And we have already discussed that rate of any process cannot be a negative quantity. Rate is always a positive quantity, as rate represents we are moving in a forward direction, and when we are moving in forward direction, so the change will be positive. So the rate has to be positive as well. So since DNA is negative and rate has to be a positive quantity, so what we will do, we will use a minus sign here to compensate the negative value of DNA. Now negative value of DNA, negative will become positive. So we can write it as minus 1 upon V DNA over dt. And now this is the rate in terms of product B, this is rate in terms of reactant A. On right hand side you can see that the equation is different. The nature of the equation is same, but the meaning is different. Here we have minus, on that side we have plus. So that's why notation has to be different as well. So that's why with RA we will use one minus sign here as well. And either you can write it as minus RA or you can write it as RA negative. Meaning is same. So for reactant we define rate like this. For product we define the rate like this. On this side, if we talk about these two negative signs, so you cannot cancel these two negatives because this minus sign is the mathematical sign. It is a mathematical negative value, mathematical negative sign, which can absorb in any equation. Okay, and this minus sign is just a notation. And why we are using this notation? Because this rate is different. This rate is in terms of product B, where B is appearing during the reaction, and this rate is in terms of A, where A is the reactant which is disappearing during the reaction. So this minus sign is used to denote that, it used as a notation to indicate the disappearance of A. So if someone asks you, then we will say minus RA means rate of reaction in terms of disappearance of A. RB means rate of reaction in terms of formation of B. And remember guys, if we have some equation like Z plus minus RA, then you cannot write it as Z minus RA. That will be a wrong approach, because this minus sign on left hand side is just a notation, it is not the mathematical sign. But if you have some equation like Z plus minus 1 upon V dna over dt, then obviously you can write it like this, because this minus sign on the right hand side is the mathematical sign which can be absorbed in any equation, in any mathematical equation. So this is the right approach. Okay, and that's how we can define the rate of reaction for reactant A and for product B. Why in CRE we always talk about the most, we talk the most about reactant rates only. Reactant rates means rate of reaction in terms of reactant. You can also talk about the product, no problem. You can talk about the rate of reaction in terms of product as well. It's not a big deal. Is it clear, guys? Can I erase this? Have you noted? Note कर लिया? Hello guys, is it clear? Say yes, no. Yes, yes, yes. Okay. So can I erase all this part? Okay, wonderful. Now the answer for your question, Ketan. Why we talk about the rate of reaction in terms of reactant only? मतलब in terms of reactant mainly in most of the cases. See, we can also talk about the rate in terms of product. It's not a big deal. But just try to understand. Suppose you have 1 lakh rupees in your pocket, in your wallet. Okay, and you went for you are going for some shopping purpose. When you enter in a mall, you spend some of the money to purchase some products, either clothes, accessories or anything else. So after purchasing those things, if some of your friend ask you, let's go to this showroom, let's say, and let's buy some shoes as well. Okay. So, before going into that shop, before buying those shoes, what will you see? Will you check the remaining amount of money or will you check the receipts of those products? Obviously, the remaining amount of money. You will not concern with the products, the amount of those products now, which you have already purchased. You are concerned with the remaining amount. What you can do further with that remaining amount. So this is the answer. Why we mainly use the rate in terms of reactants. Because if reactants are available, then reaction may happen. If reactants are not there, if all of the reactant has been completed or converted or you can say exhausted, then what will you do with the reaction? If product is formed in limited amount or large amount, doesn't matter. Every reaction depends only on the reactants. If reactant is available, reaction may take place. If reactant is not there, then definitely reaction will not be there. So that is the answer. So next point is relative rates of reaction. So suppose, remember this chemical reaction now, okay, because we are going to use this chemical reaction in everywhere, in entire CRE, at the time of designing of reactors, in solution thermodynamics as well. So remember this chemical reaction. A unit of A plus B unit of B gives C unit of C and D unit of D, where these small letters A, B, C, D represents the stoichiometric coefficient of the respective components, and capital letters A, B, C, D are the chemical species. Okay. So, what is the significance of stoichiometric coefficient? Before we talk about any chemical reaction and further the kinetics and designing of that reaction, let's talk about the basic part, stoichiometric coefficient. So what do you understand by this term? What is the significance of this stoichiometric coefficient? If you can explain, then answer this. If you can't explain, if you don't have any idea, then just simply say no. At least respond. Okay. तुम कुछ बताओगे? हाँ ना, कुछ तो बोलो. कोई नहीं. After completing my BTech, I was also zero in CRE. I was having zero knowledge of this subject. And now I am teaching this subject from last 7 years. And my students also teaching this subject in some other coaching institutes. So guys, tell me. You will also learn. बस थोड़ा focus रखो, तुम भी सीख जाओगे. What is the significance of stoichiometric coefficient? Stoichiometric coefficient inform about the proportion in which molecules react for a chemical reaction. Oh my God. Wonderful. Stoichiometric coefficients help us to identify the ratio, or you can say proportion, in which molecules are participating in the reaction. Okay. Like if I want to read this statement, if I want to read this chemical reaction, I will say A molar unit of A will react with B molar unit of B to give C molar unit of C and D molar unit of D. Okay. For example, suppose I have ammonia synthesis. We will talk about this reaction n number of times. So I will say 1 molar unit of nitrogen is reacting with 3 molar unit of hydrogen to give 2 molar unit of ammonia. Typing mistake, sir. What mistake? I didn't know. N16 and constant. We get a base of for the quantities for the complete reaction to occur. It gives us the idea of the ratio of the reactant reacted and the product formed. Okay, Sakib? The stoichiometric coefficient are numbers of molecules present in the reaction. No. No, 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 no. No. No, no, no. A stoichiometric coefficient never represent the number. Okay, a stoichiometric coefficient never indicate the amount. Remember this. A stoichiometric coefficient just indicate the ratio. the proportion in which components are participating in the reaction. Okay, that's why I am writing this example. Suppose my feed has 10 moles of nitrogen and 27 moles of hydrogen. Now, at any moment, if 3 moles of nitrogen reacted, suppose if 3 moles of nitrogen reacted, okay, during the reaction at any time t, if you see, if 3 moles of nitrogen reacted in the reaction, then what will you say? What will be the amount? So we can see that 3 moles of nitrogen reacted. 1 mole nitrogen react with 3 mole hydrogen, so 3 mole nitrogen will react with 9 moles of hydrogen to give 6 moles of ammonia. Okay. At another time t, suppose if we have 7 moles of nitrogen reacted, if 7 moles of nitrogen reacted at that time, then what will be the amount? Then amount will be different, the numbers will be different. 7 moles nitrogen will react with 21 mole of hydrogen to give 14 mole of ammonia. Okay. So remember guys, stoichiometric coefficient never tell us, never give us the information of the numbers. It also signifies the ratio or proportion in which molecules are participating in the reaction. Okay. With the help of these stoichiometric coefficients, we can calculate the numbers, but stoichiometric coefficient does not talk about the number. In which molecules react with each other and formed. Okay guys, so now let's talk about the relative rates of reaction. So I am writing directly what is the relative rates. We will see this after the mole balance. So relative rates of the reaction. So here one thing is clear and this mathematical equation is basically known as reaction equation. Okay, where we can understand the left hand side part represents the reactant and right hand side part represents the product. So relative rates of the reaction will be minus Ra over A equal to minus Rb over B, that will be equal to Rc over C, that will be equal to Rd over D. Now just try to understand. All of us, okay, all of us. Suppose all of us are sitting in a train. Train is moving with a speed of 100 miles per hour. All of us are sitting in a train and that train is moving with a speed of 100 miles per hour. So for any stationary observer, who is standing on some platform, what will be the speed of train? 100 miles per hour. What will be the speed of the person sitting in the train? Tell me guys, what do you think? For this stationary observer who is standing on any platform, if he want to see any person who is sitting in that train, what will be the speed of that person for him? Same as train, that is 100 miles per hour. Okay. So similarly, just try to understand, if I am talking about the reaction, if I am talking about the rate of reaction, okay, rate of reaction, I am talking about the rate of reaction. Reaction means combination of all these components. Okay. Reaction means combination of all these components. All these components are present inside that reaction. So if I am talking about the rate of reaction, then the rate of reaction should be same for all of the components. As all of us are sitting in the train, if train is moving with a speed of 100 miles per hour, then all of us also are moving with the same speed, 100 miles per hour. Similarly, if our rate of reaction is 100, then the rate of reaction for all of these components should be 100 as well. Okay. Then, let's talk about this. Is it same or not? So suppose for this chemical reaction, at any time t, if I check the rate, then suppose 7 moles nitrogen reacted per second. So what for nitrogen, what is the rate? 7 mole per second. We know that 1 mole nitrogen react with 3 mole hydrogen. So 7 mole nitrogen will react with 21 mole hydrogen per second. 1 mole nitrogen give 2 mole ammonia. So 7 mole nitrogen will give 14 mole ammonia per second. Now see, the rate of each component is different. When all of us are sitting in a train is moving with the rate of 100 miles per hour, then obviously the speed of all of us will be same as train. We cannot have the different speed until and unless we start to move. Similarly, when we are talking about a about a reaction. So when the reaction is moving at a certain speed, reaction is moving at a certain rate, then the speed for all these components which are inside the reaction should be same. But we can see it is different here. So to make it same, what you can do, just divide this by their respective stoichiometric coefficient. For nitrogen, that is 1. For hydrogen, that is 3. For ammonia, that is 2. Now, what is the result? 7 moles of nitrogen per second, 7 moles of hydrogen per second, 7 moles of ammonia per second. Okay, if you want to understand this, you can divide this by volume as well, because volume of the reaction mixture will remain same throughout. For all these components, volume will remain same at any time. Okay, so if you consider volume or not doesn't matter, but now you can see the rate is different. Now the rate is same for all the components. So it means this is the rate of reaction. This was not the rate of reaction, but this is the rate of reaction. So when you divide the rate of reaction by their stoichiometric coefficient, okay, mode of stoichiometric coefficient, because if I is the reactant, that will be minus Ri. If I is the product, it will be plus Ri. So this value will be equal to R. And what is this R? R represents the rate of reaction, which has to be same for all of the components, and as you can see now it is same. After dividing by their respective stoichiometric coefficient, it has become same for all the components. Okay. So what is minus Ra means? So minus Ra means rate of disappearance of A per unit volume. Volume of reaction mixture. What is RC? RC will be rate of formation of C per unit volume of reaction mixture. So minus Ra over A, minus Rb over B, Rc over C, Rd over D is basically the rate of reaction. Only minus Ra is not the rate of reaction. Okay guys? So is it clear to all of you now? The relative rates of reaction? The rate of reaction? Moksh Prasad, yes. Okay, so out of so many guys and girls, only it is clear to only one person, and rest people are sleeping. Okay, अब भी आप भी जग गए. Yes, yes, yes. Okay, thank you guys for your response. It is very important for me. तुम्हें clear है? Now what we can understand by this relation? That we will discuss after some time. So let's do some numericals, 1-2 problems related to this, then we will move further. Sir, why not to take coefficients negative for the reactants? Because rate is already in with the negative sign, minus R. Okay. This is already having the negative thing. Just try to understand. Minus Ra, what in terms of A, what was the rate? Ra equal to 1 over V dNA over dt. Since dNA is negative, dNA was negative. So to compensate the negative value of dNA, we used one minus sign here. Okay. Now because of this minus sign, this entire rate has become a positive value. So that's why this has to be positive as well. Otherwise, positive divided by negative will become negative, and rate cannot be a negative quantity. I hope it is clear. There are no negative coefficient. Yes. We will not use any negative stoichiometric coefficient because we have already included that minus the effect of that negative sign in this, in the rate, okay, to make it positive. So now guys, we put coefficients negative. Actually in some simulation software, see guys, Ketan, if you, those simulation softwares, those are different things. And simulation softwares, I have also used so many things. There they use a general chemical reaction like AA plus BB plus CC plus DD equal to 0. Okay. We will discuss that in solution thermo as well. But any chemical reaction can be represented by this expression. If you have 4 components in the reaction, then it will become nu A of A plus nu B of B plus nu C of C plus nu D of D, that is equal to 0. Okay. Now how will you identify? How the software will identify which of this component is reactant or product? So if this is negative, it means A and B are reactants, and if this is positive, it means C and D are positive. For example, minus A, minus B plus C plus D. Now just solve this. It will become AA plus BB equal to CC plus DD. And for chemical reaction, either use equal or you can use single arrow. Meaning is same. That's why we use negative sign in simulation software. So there is no need of confusion. You should not get confused. It's simple. Okay. Just understand. So guys, note down one simple numerical. The molar rate of disappearance of nitrogen, is 196 gram per second. 196 gram per second. Calculate the rate of formation of ammonia. Calculate the rate of formation of ammonia. So guys, tell me what is the answer. From next class, bring your calculators as well. Keep your calculators along with you because we will all discuss some numericals. क्या आंसर? $392 what? Moksha? 392 kilometer per hour, 392 light years, 392 seconds, 392 meter per second, 392 kg. Oh, 392 gram per second. Huh? 932. So you change your answer from 392 to 932. Okay, 392 gram per second. Be careful with your units. Chandan, 392. Ketan, 14 mole per second. Arisha, 392 gram per second. Ankita, 92 gram per second. Okay. Ankita, it's 98 gram per second. Okay. Swani, 98 gram per second. First thing first, you will appear for the GATE exam, and I hope all of you know that in GATE exam, as per the last year pattern, you will have only two types of questions, MCQ and NAT. In MCQ questions, 4 options will be there. You have to choose the one option which will be correct. And in in NAT questions, that is numerical answer type, you have to type your answer the numerical value. Okay, and if your answer is within the range, you will get full marks, otherwise you will get 0. And in most of the NAT type questions, they mention that you have to answer in these units or in these units. Okay, that is not a big deal. But if it is not mentioned the units, means in which units you have to answer, that is not mentioned, then what to do? Like this question. Question is there, you have to give the answer, but it is not mentioned in which unit you have to answer. So remember guys, one simple common sense. If someone asks you a question in English, then obviously common sense say answer in English. If someone asks you a question in Hindi, then common sense says answer in Hindi, reply in Hindi. If someone asks you a question in French or any other language, if you know that, then answer in that language. Okay, that is a common sense. If you know, if you don't know that language, then just simply obviously ask them to convert, translate that. So now the question was given, the data was given in gram per second. So our common sense says answer in gram per second. Simple. So for ammonia synthesis, N2 plus 3H2 gives 2NH3. We know that relative rates will be minus Rn2 over 1 equal to RNH3 over 2. That means RNH3 is equal to 2 times of minus Rn2. Simple. But this rate is given in gram per second, and this relative rates are valid in molar units. These relative rates we have proved in molar units. Okay, so this relation is valid only and only when these rates are represented in their molar units. So what we will do, we will change the rate of disappearance of nitrogen in molar units. Initially it is 196 gram per second, and you know that to change mass into moles you have to, what is the molecular weight of nitrogen? 28. And what are the units of molecular weight? Gram by gram mole. So you can see you have to divide by the molecular weight. So it will be 28 gram by gram mole. So now this entire thing is converted into molar units. So this relation is valid. You will get rate of formation of ammonia as 28, 14, 98, 14, 5, 84, 14, 7, 2, 14 mole per second. This is the answer. But data was given in gram per second, so we will convert this into gram per second again. So for ammonia we know that what is the molecular weight? 17. And what is 17? 17 gram by gram mole. So here you can see mole will get cancelled and you will get your answer. That will be 7, 4, 8, 238 gram per second. Three ninety two, 932, 92, 98, 392, 98, 392, 392, 392. So that is not the correct answer. The correct answer is this. 17 is the molecular weight of ammonia. Is it clear, guys? Remember, these relative rates are valid only and only when rates are represented in the molar units. Okay. So let's take one more numerical. Give me the example of any. Give me any chemical reaction, guys. कोई केमिकल रिएक्शन ही याद नहीं आ रही इसके अलावा अभी. जो आ रही हैं वो बहुत बढ़िया. Who cares? The molar rate of disappearance of phosphine vapor is given as 100 mole per second. Calculate the rate of formation of hydrogen in gram per second. Phosphine decomposition is this. C plus O2 gives CO2. मजाक चल रहा है. इतनी सिंपल रिएक्शन की न्यूमेरिकल करोगे तुम. गेट एग्जाम में तुम्हें सिंपल ही मिलेंगे क्वेश्चन, बट इन क्लास मैं सिंपल नहीं करा सकता. क्या बोलोगे तुम बाहर जाके कितने सिंपल क्वेश्चन कराते हो? ऐसा थोड़ी होता है. Now guys, don't ask me the molecular atomic weight of phosphine. Do you know the atomic weight of phosphine? Yes or no? P it is 31, for H it is 1. In case what is 300 gram per second? Answer. Okay, let's see. 150 mole per second, 2 gram by gram mole, 300. Okay, that's correct. Moksh 300 G per S. Thank you for the correction. That's what I was saying. Gram is represented in small g, not capital. So guys, what will be the molar relative rates for this? Minus RPH3 over 4 equal to RH2 over 6. So RH2 will be equal to 3 by 2 times of minus RPH3. Okay. So rate of disappearance of phosphine is given as 100 mole per second. So obviously you will get the rate of formation of hydrogen, that is 150 mole per second. But we have to answer this into gram per second. So for hydrogen we know that molecular weight is 2 gram by gram mole. So it will be 300 gram per second. Simple. Okay. So this is something about the relative rates. In next class we will talk about the factors affecting the rate of reaction. After that, that is power law, rate law, what is rate equation. Then we will also discuss the use of relative rates to identify the rate equations in terms of respective components. Okay. We will also discuss the mole balance over chemical reactions. After that we will discuss some basic terminologies like order of reaction, molecularity, what is the significance of molecularity, what is the significance of order of reaction, why order of reaction can be negative, can be 0, but molecularity cannot be 0 or negative. We will discuss all these things, and if after that, obviously at last we will talk about the methods to calculate the rate constants. And still, if video is stuck, then just watch the recording if any part has been missed. Maybe there is some issues going on from afternoon, after 12 p.m. till 12 p.m. everything was perfect. I don't know what happened. We will see to this. Okay, and maybe from next time it will not happen. And this is some. After tomorrow's class, I will give you the first assignment of the CRE. Okay. So that's all for the day, guys. Thank you. See you in next class. So when you come in the next class, remember you have to find out one question. I have given you one question to read. That is, what is phase? How will you define the term phase? Okay, I am not talking about the phase which we use in electrical engineering. I am talking about the phase which we use in materials, in physical chemistry, chemical engineering. When will the next class start, sir? Next class will be at 2:30. I think your math for 2nd July batch, there is no next class. Your next class will be tomorrow. For 2nd June batch, your math class will be at 2:30. And for more information, you can contact on the given numbers. See you guys tomorrow. Thank you.